When traffic breaks in Cisco ACI, the real problem isn't just that it's down, it's not knowing whether you're dealing with endpoint learning, policy, subnet scope, and flags, routes, forwarding. In this walkthrough, I'll show you a practical way to narrow it down fast. Start with the symptom you can actually observe: what is failing, which source is talking, which destination should respond, and what path should that traffic take through the fabric. From there, you'll have a repeatable troubleshooting sequence you can use in real incidents instead of chasing guesses. That keeps you out of guesswork. Instead of hunting randomly, you narrow the problem into 3 layers: endpoint learning, policy, or forwarding. A lot of ACI problems start with endpoint state. The endpoint may be learned on the wrong leaf, attached to the wrong EPG, or still showing stale information after a move. Then come policy failures. A contract may be missing, the subject may not match, or the filter may block the protocol or port the application actually needs. And sometimes the policy is fine, but forwarding still breaks because of a bridge domain or VRF mismatch, or because the fabric path through the leaves is not behaving the way you expect. First, verify where the source and destination endpoints are learned. If the fabric doesn't know where an endpoint is, every later check will mislead you. Next, confirm each endpoint is attached to the EPG you expect. An endpoint in the wrong EPG can make the traffic look like a contract problem when it's really a classification problem. If learning looks inconsistent, think about mobility or stale entries. You might see an endpoint move between leaves or stay mapped to an old location longer than the application can tolerate. Once endpoint learning checks out, EPG subnet flags can change the outcome. In Cisco ACI, reachability relies on subnet definition on the EPG or bridge domain and how the fabric handles it locally, externally, shared, or with a gateway. When traffic fails, check the subnet configuration and flag. Start with advertised externally. Ask if devices outside the fabric need a route to this subnet. If yes, and the flag is missing, verify subnet attachment, enable external advertisement, and ensure L3 out design matches. Check the export route control subnet flag to push the prefix outbound. Next, check shared between VRFs. Shared services designs can break if DNS, load balancer, or firewall subnet isn't reachable across VRFs. Missing or inconsistent flags can cause traffic failures despite correct contracts. Ensure subnets are private or shared by matching import route control subnet and shared security import subnet controls. Then look at no default ACI gateway. Check if ACI should be the first hop for host. If the default gateway is on a firewall or another device, ensure this setting matches. Otherwise, you may troubleshoot the wrong path. Query IP is more specific, but still worth checking when multicast is involved. If receivers are unstable or group membership looks wrong, verify that the query address is valid for the subnet and lines up with the intended multicast design. Focus on whether the subnet should be private, shared, or linked to a different gateway. Compare EPG flags, bridge domain, and VRF design to clarify the problem. When traffic behaves oddly in ACI, start by verifying the bridge domain and the VRF. That tells you whether the endpoint is even being evaluated in the forwarding context you expect. If that context is wrong, context can look correct and the flow can still fail because classification is happening in the wrong scope. Practical takeaway: confirm bridge domain and VRF first, then trust what policy is telling you. Here's the cleaner troubleshooting order. First, confirm the destination endpoint is learned in the right place. Second, confirm policy should allow the flow. Third, check which subnet flag controls the forwarding decision. If the path depends on external reachability, verify advertised externally. The fabric may know the endpoint internally, but return traffic still fails if that route was never exported through the L3 out. If the design uses shared services or an external default gateway, validate that the subnet flags match that design. Otherwise, the fabric makes the forwarding decision from the wrong routing context or gateway assumption. Practical takeaway. Endpoint learning tells you where a host is. Subnet flags tell you whether traffic can actually get there. Use a practical subnet flag checklist. First, read the subnet. Next, match the flags to the intended design. Then confirm whether the traffic path supports route advertisement, VRF sharing, or gateway behavior the way you expect. Practical takeaway. If the flags do not match the design, the packet path will not either. Start in Epic and inspect the EPG subnet directly. Confirm the subnet exists where you expect it and confirm whether it is defined under the EPG or inherited from the bridge domain. Then check the flags one by one. In HC, those flags drive forwarding behavior, so a single wrong setting can make the fabric behave exactly as configured and still look broken. Practical takeaway. Verify subnet location first, then validate flags before you assume the policy is wrong. Next, line up the subnet with the bridge domain and the VRF it belongs to. Ask one clear question. Is this subnet supposed to stay local, be advertised externally, reach shared services, or support a specific gateway model? If that expected behavior does not match the bridge domain and VRF design, the symptoms look like forwarding trouble, even though the real issue is design mismatch. Practical takeaway. Validate bridge domain and VRF intent before you debug packet forwarding. Once endpoint learning, policy, and subnet checks all look right, the next move is route verification. At that point, you're no longer asking whether the flow should be allowed. You're proving whether the fabric actually has the routing and path logic needed to make the forwarding decision. This is where you verify the actual routes on the leaves that matter to the flow. Check that the expected prefixes exist in the correct tenant and VRF and make sure what you see is consistent with the path this traffic should take. If the route isn't present in the right context or it shows up on the wrong nodes, the fabric is already telling you where to look next. In ACI, a route showing up in the table is only part of the story. You also need to judge whether it's the right route, whether the next hop is actually reachable, and whether that route lives on the leaves that should participate in this flow. Those details decide what the fabric can really do when it has to forward the packet. So, route verification isn't optional in ACI. It's one of the fastest ways to prove whether the end-to-end path is real or only assumed. The big takeaway is to use a repeatable method. If you follow the same ACI troubleshooting sequence every time, you isolate issues faster and defend the fix with a lot more confidence. Use that same sequence on your next ACI incident and you'll isolate the real failure domain a lot faster instead of guessing where the break might be.